OMG, you guys see this? I'm cutting up my competitors' grow lights to see how they're built. This video of the series is going to make a lot of people in the grow light industry very uncomfortable. To those people, here's our CEO's contact information. Hi, I'm Eric Keystone. I'm Senior Product Developer here at SpecGrade, located in Columbus, Ohio. Since 2010, my team and I have been designing, engineering, and building LED commercial industrial lights. And since 2016, we've been doing the same with LED grow lights. I'd like to think that we've learned a thing or two along the way about LED lights. Whether you're cultivating cannabis or vegetables, in a greenhouse or indoors, the bottom line is all you want from a grow light is that 5 years from now and after over 15 harvests, you want nothing more than to experience that the grow light will perform as well on the 15th harvest as it did on the first one, right? To get you there, I'm here to highlight one crucial grow light issue that doesn't get enough press, and that is thermal management. But that term, more than just about anything else, can significantly impact your ROI big time. I'm going to show you something in a minute that even some of our competitors haven't seen with their own lights. Okay, let's get started with the term thermal management, or heat management. It's easy to overlook the impact of environmental conditions on LED performance, and on the plants. Failing to consider such factors such as ambient temperature, humidity levels, and exposure to external elements can lead to suboptimal performance and ultimately system failure for each of your LED grow lights. In terms of your plants, excessive heat from grow lights can stress or damage plants, affecting their health and productivity, such as light burn, powdery mildew, pest infestations, and nutrient burn, ultimately impacting the plant's roots, foliage, and flower production. Make sense? Okay, now let's talk about grow lights and your ROI. Hang in there with me, I'm going somewhere with this. If the LEDs burn too hot, it causes rapid degradation of LEDs themselves, which results in less light output, shorter life, and spectrum change while impacting your HVAC. Listen up for this for a second. The rule of thumb is that for every 1% decrease in light output, there's 1% less yield. That's why, if a grow light degrades over 10%, it's considered at the end of its useful life. This degradation may prompt you to increase your output, impacting your ROI. Coupled with premature degradation of the driver or power source due to excessive heat has arguably been the cause of most grow light failures across the country. And if that's not bad enough, it will also cause color changing or color shifting, meaning your proven spectrum or the cornerstone of your profitability is going to change over time. Sorry, I get a little emotional about this. What's happening is LEDs are coated with various phosphors, which helps to create a spectrum to mimic sunlight. Excessive heat will burn off the phosphors, causing color changing or shifting. And while this might not matter much for parking lot lighting, roadways, or other non-horticulture, it's crucial for your grow operation, as your plants rely on a proven spectrum for optimal growth. Okay, without getting too nerdy, the solution is really simple, and this is what to look for when you purchase your LED grow lights. Heat sinking. Yep, heat sinking is crucial for all electronics because it transfers heat away from the PCB components while in use for this reason. Aluminum, which is an excellent cost-effective conductor of heat, brings the operating temperature down, and each square inch of surface area of the circuit board is attached to an equal size of aluminum. By adding aluminum fins, will further enhance heat dissipation. A well-designed heat dissipation system prevents overheating, preserving the performance and life of LEDs. It stabilizes the temperature and not stressing your plants. Look, our cell phones are electronic devices, right? Then why aren't the casings plastic? Answer, it's because the casing doubles as a heat sink. Don't you think someone would have come out with plastic casings by now to cut costs? Okay, put your seatbelts on. Earlier, I promised you that I'm going to show you something about our competitors' lights that they themselves probably haven't even seen, because most of them are just resellers of low-cost Chinese manufacturers. Most grow light heat sinks look like this one. The critical portion of the heat sinking is this small strip of aluminum directly behind the printed circuit board, because, as any thermal engineer will tell you, the thermal transfer of heat is 100% about the surface area of the PCB to the surface area of the heat sink. At the end of the day, the longevity of the light and the health of your plants is all dependent on this. The rest of this is decoration, because heat doesn't travel like this very well. So, why don't all LED companies know this? The engineers in China probably do. But once again, you guessed it, it will also cost them money and make their prices higher. Also, by making room for more heat sinking, you're widening the printed circuit board using more low-powered LED chips. The result is that the LEDs burn cooler, and more LEDs there are over a wider area, the better the uniformity. That's huge. But it costs more money. Spec Grade does it because we're fine with the lower margins and we don't have a bunch of investors and overpaid executives. Look, your lights will perform the same in the 5th year as they did in the 1st year. Contact us if you'd like to chat about it further. You might also want to watch this next video from the US Department of Energy's website regarding color shifting or color changing.